Free fall is a misnomer. It's not just objects that are falling. It does include objects that are falling. So here I'm going to draw a baseball. And so if that baseball is falling, we say that's in free fall. Another type of motion that would be in free fall is what if the baseball is going upward? What if you just throw it up into the air? It is also in free fall, even though it's not technically falling, it's going up. And the last one would be even if you said the ball goes up and then comes back down, it is in free fall all those times. So that's kind of confusing. Even when it goes up, it's not falling. So why is it called free fall? Free fall is defined right here. It's when an object is acted on by only one force, which is gravity. So as soon as you let go of it and it's falling, or if it's moving in the air by itself, right, just under its own motion and affected only by gravity, that is considered free fall. And so we look at these pictures here to kind of illustrate what that looks like. So I did this in class. I dropped a golf ball and a tennis ball. So here's a golf ball with all the divots on it. And here is a tennis ball. I don't really remember what it looks like. Let's make it look like that. And what Galileo discovered is that they fall at the same rate. They will be increasing in speed, so they actually have an acceleration that pulls them downward due to gravity. Let's fix that here. There we go. And they will increase in speed. And for example, after 1 second, it will be moving. Galileo figured this out. It will be moving 9.8 meters per second downward after 1 second of falling. And after 2 seconds, it would be double. So what's double here? That would be a 6, 18, I think that's 19.6 meters per second. So as objects fall, they increase in velocity moving down. In this class, we call this the acceleration due to gravity. Actually, anywhere you call that acceleration due to gravity. And it is actually 9.8 meters per second squared. That means that every 1 second that it's falling, so from here to here, that is a difference of 1 second, it has increased by 9.8 meters per second. And so that's where the units meters per second squared come from. It's 9.8 meters of speed increase per 1 second. And so meters per second squared. Okay. But you don't have to remember any of that. But what we do have to remember is what that value is. It is 9.8, but in this class, for our convenience, we are going to use 10 meters per second squared, and let's say downward. The direction is very important there. Gravity does not push up, it pulls down. Cool. Next part here, the sign convention. We know that if we go right, we'd like to use a positive, and if we move left, we like to show that uh, with a negative sign. When objects are falling straight to the ground, so you drop something, so this would be the downward direction. We use a negative for those numbers. And if you throw something into the air while it's moving up into the air, that's a positive number, so we'll say that upward is positive. That's what we call our sign convention. It helps us keep track of direction. And it was completely just agreed upon. It's just something decided. And that's what we're going to use in this class. You might recognize these variables if you have watched the video or attended the class where we talked about constant acceleration. The difference is instead of x's, we have y's. This is the height, the initial height, or the height of an object at time 0. And look at that, I've run out of space. Height will be measured in meters. Y would be the height at a later time, which is also in meters. You may remember this from the other lesson. V naught, that's just the velocity. Velocity at time 0. This is the velocity at a later time. So t equals something else. And by the way, velocities are in meters per second. Those are the units. Acceleration, this is very specific. This is the acceleration due to gravity. Now, I'm not just going to put units here, it's meters per second squared, but because this number is always going to be 10 downward, and when we do the math, we're going to write negative 10, we'll just write that that is the value. It's not just units there, but that value is always 10 for the problems that I'm showing you today. And of course, t is time that we are used to, that's in seconds. And we will just do one example here. Whenever you solve these problems with these variables, we should make a list of these variables the way that we see them here. Don't change up the order of the list, but we will write them down. Now let's read the problem, but there's numbers we can put in there without even reading it. It says a golf ball is dropped from 2 meters above the ground. How long does it take for the golf ball to hit the ground? And what is the golf ball's final velocity? So let's break this down. So they give us 2 meters. We'll start with that. A golf ball is dropped from a height of 2 meters. That is the height of the object at time 0. So we're going to put 2 meters here. Now it is falling to the ground. So what is the height of the ground? That should be 0. The height of the ground is 0. When you drop something, if you think about this, when you drop something and it starts falling, we said that after a second it's going 9.8 meters per second, but at the instant that we drop it, it started from 0 speed. So this word dropped is very important. When you drop something, v naught will be 0. So you can always expect that. A is the acceleration due to gravity. That is always negative 10, as we showed there. So we will put in negative 10. I think that's all the information to give us. With these problems, if they give you 4 numbers, that's all you need to start solving things. Part A says how long, implying the time. How much time does it take for the golf ball to hit the ground? And so we're trying to solve for t, but we want to use an equation that does not have v, so we need to exclude v from our list of equations. So clearly this one is out, and this one is out. We can't use those. We have to use the middle one, and hopefully the middle one has t, and of course it does. It's right here, t, and t squared. So to get points, you always have to show the equation without any substitutions. Y is 0. Y naught is 2. V naught is 0. So if this is 0, any 0 times t is still going to be 0. This whole thing is 0. Okay, let's clear this up, 0. So I'm not going to write it down here. You don't have to. Anything plus 0 is just whatever is there, so we're just going to leave it out. We have 1/2. We're going to substitute a. When you substitute, you should always put things in parentheses. And t, we don't know it, so we just have to leave it. We'll simplify this for a moment. 1/2 times negative 10 is negative 5 t squared. Remember, you cannot add 2 and negative 5, or you can't subtract them, in other words. We have to move things to the opposite side of the equation. And we're not going to touch the negative 5 yet. We're going to subtract 2 from both sides. That cancels. We're going to rewrite it. 0 minus 2 is a negative 2. And we have negative 5t squared. We want to isolate t. So we need to get rid of negative 5. We have to divide it. And the negatives will cancel. Your calculator, if you type this in, should give you 0.4. But we're not finished yet. We have t squared. We want it to say t. And so what we have to do here is square root. We need to get rid of the square and what we do to one side, we have to do to the other side. I believe this is 0.63, but let's type this in the calculator. The square root of 0.4 is 0.63. 0.63. The units for time are seconds. You can put it here in the list, but I will always grade it with your work. All this stuff here, all the way going down, is how I grade it. So make sure you do show it there. I will not grade it from the list over here. For part B, all we have to do now is, that was part A. For part B, all we have to do now is figure out the final velocity. In other words, as the golf ball is falling to the ground, I want to know how fast, here are the divots of the golf ball. I want to know how fast is it moving, with what speed does a golf ball hit the ground with, in other words. So yeah, technically it's a little bit lower, but you guys can imagine it's like when it's falling, with what velocity did it hit the ground with? But there's nothing tricky here. All we have to do is calculate for V. You can use any equation you want for V because we have all the numbers. You could use equation 3 because here it is. But we will instead use equation 1. It's very easy. And we don't know V. V naught is 0. Substitute A and substitute T. A is negative 10 and T is 0.63. Try typing this in your calculator. You get negative 6.3 meters per second. But we want to take this one step further. That's the answer. And ask yourself, what does the negative mean in this case? We talked about our sign convention. When we talk about upward and downward motion, negative means downward. And so you can also write this as 6.3 meters per second downward. We either write the negative or we write the word downward. And so this is our answer here. There is something good about writing it this way. It's that if you ever use this number in a calculation, you want the negative because you can't put downward in your calculator, but you can put a negative in your calculator, and then it keeps the numbers correct. Cool. Example 2, you can do it on your own. It's very similar to this problem. Mathematically, you don't have to square root anything. Is that true? Let me think about that for a second. 0.8. Yes, that is true. So mathematically, it's a little bit different, maybe a little bit easier.